Hey, welcome up to this week's Tech Talk. You're joining Brad Monday and myself live. We're here on Discord. Was this Thursday, November 30th? No, it's not November. Thursday, March. Is it March 30th, Brad? Okay. I'm either very ahead of schedule or very behind schedule. And we're here to talk about the latest release of Modzy, version 1.7. This release, which is coming out in just a couple of days, so we're giving you a slight preview, has a huge improvement to the way that our customers can basically deploy and manage their edge devices. One of the big pieces that changed under the hood is that we replaced our event management queue service. We had previously been using Kafka, and we upgraded to another platform called Nats. If you're not familiar with it, it's amazing. Really great technology. The folks over at Synadia who invented Nats worked with us pretty closely on the development of this offering. But in a nutshell, we've added in two-way communication between an instance of Modzy and hundreds, thousands, tens of thousands of edge devices anywhere in the world. And that makes it just an incredibly efficient way to be able to use AI across a lot of different devices. So, Brad, can you share some examples of when we say an edge device, like what kind of devices that could be? Some of the things that we've played around with, some of the things we've done with edge?
Yeah, absolutely. We'll actually show you a couple examples of these later in the talk, and Seth will maybe change his phone so you can see what that actually looks like. But when we say edge device, remote device, it can be anything from a traditional edge device, things like a Jetson Nano, a Raspberry Pi. I've got it's not hooked up right now, but it's an Intel Upboard, right? So very small form, kind of traditional edge computers. But then when you think about some other examples, it could be an individual's laptop. It could be a on-prem server somewhere in a data center. It could be a node that you provision in your cloud instance. Really this means anything. And so what we'll show you later on are a couple examples of how this might look, in a kind of production setting. Some of these are examples our customers use, but yeah, when we're talking about edge devices, it really spans kind of a wide variety of computer types and variants.
Yeah, that's right, Brad. It's the word edge is one of those terms that often gets used in a lot of different ways, and we're very inclusive. The way I like to think about it is any computer that is not in your cloud or in your on-prem cluster could be an edge device, because for whatever reason, there's a need to run machine learning in that computer in another location. And anytime that's the case, you can treat that as essentially a network, a fabric of edge devices. So let me actually just walk you through real briefly kind of the new features in 1.7, and then we'll show you some cool live demos that we've built out that use all of this magic we've put together. So kicking things off right here, and let's jump into the product. Okay, so for those of you who are Modzy customers, you'll be familiar with a lot of the things we're going to show you, but I'm going to move your attention over to our actual edge device management pane pretty quickly here. So within Modzy, you have the ability to deploy machine learning models from a number of locations. Our support for an open source project called Chassis makes it really pretty straightforward to take your Python-based machine learning models and turn them into lean, efficient container images. One of the reasons why that's really nice, in addition to the fact that you can compile those devices for both ARM and x86, is that those container images, they can run in your central Modzy hub, again, in the cloud, on premise, or you can go ahead and send those models out to a remote edge device. So we're going to go ahead and actually show you an example of how you do that with 1.7, and we're going to do that with a model that we pulled in from Hugging Face. So I'll pull this guy up here right now. We've got a little tiny BERT transformer model, and it takes in text and it returns essentially sentiment type results. So what you can see here, once you send a little bit of text to this model, it's going to return with some class predictions. Hopefully we'll be able to send some data over to an Intel Upboard, a little single board computer running over here on my wall. I'll show you in just a second, and be able to talk to it just like we talk to it in the cloud. So let's go ahead and create a device group and just see how all this stuff works. So I'm going to create a new device group, which you can use to create essentially collections of different edge devices. They can be tiny little single board computers like this, or big edge servers, which you'll see from Brad in just a second here. And I'm going to call it my NLP edge bot device group. So this is going to be just a standalone device. It's going to be running Docker on that edge device. And then we're going to go ahead and select the TinyBert Hugging Face model right here. So we're going to send one version of this out to that location. I'll allow up to 2 devices to connect here, and then I'll create this device group. All right, so we've got our NLP Edge bot. We've created the group, we've added the model. Now we need to connect a device. So the way you do that, and this is where the new version 1.7 really adds a lot of efficiency, value, and flexibility. You can create a secure token that we'll use here in just a second to connect to this device and actually start downloading the model, the assets, the server, and then be able to start talking to it live. So here's how it works. We're going to go ahead and copy this command, and we're going to run it to download Modzy Core onto our little single board computer. So let me go ahead and pull up my terminal here. We're going to SSH into this device that I have on my local network. And if I type my password correctly, boom, here we go. We're logged in, we're on my little device here, and we're ready to go. So I'm going to go ahead and run this command just right here from the root directory. We downloaded Modzy Core, that's excellent. Now we got to go ahead and just run 2 other quick commands. I'm going to change the core binary so that it's got the permissions that it needs. And then finally, we're going to run one last command. And what this is going to do is start a server. It's going to sync that server back up with the central hub that we have running here, our demo instance of Modzy, with this secure token. And when it does that, it's going to get all the information it needs back from Modzy in order to start running this model. So here we go. We are now going ahead and pulling this container image right here. So we can see this model ID version number 1.0. That's the exact same model ID that we added to this device group. I'll go ahead and close this. It's going to download my token that I'll be able to use in the future. And if we jump over here to devices, we can now see this device is successfully connected. It's healthy. We saw it less than a minute ago. If I click in here, I can actually get all the information about this particular device. It's got 4 cores. It's got access to a small GPU on board, 1.5 gigs of memory. It's a x86 device on Linux. And here is the model that's running on this device, or will be running in a second once this completes. Now, the other really nice part about what we've done is we give you direct information about how to interact with this specific device. So using our Python SDK, you can copy and paste this code and directly interact with this model right on this edge device. So it lets us take these models and send them out to other devices all over the place, wherever we want to run them, and then be able to directly interact with those using our edge client, which is really lean, really fast, provides a couple of different ways for running inferences. So we'll jump back over here and I'll show you it is reconciling models. It's pulling the model image. I think this image size is about 2 gigs. So while we wait for that to download, I'm actually going to pass the baton back over to Brad so he can show you some live examples of what kinds of stuff you can do with Core. And then once this is all downloaded, we'll jump back over here and I'll show you this model live running on this device that we deployed together. So Brad, why don't you go ahead and maybe take it from here? And I'm going to open up my phone, switch over to Discord on my phone for a second, and show folks some of what we got happening over in our kind of lab environment over here.
If you can kind of toggle back between the screen that Seth is showing and mine, I'll first start with what Seth's showing. So Seth, in his office in Northern Virginia, has a little board of Modzy edge devices that we like to call our edge device lab. So he's got a couple different versions of the Raspberry Pi. He's got a Jetson Nano, which I believe he just showed us. That's a little up board right there, or upwards to the left. And he actually has, he's rigged up a camera It's a Raspberry Pi camera that's connected to the Jetson Nano. So for this first demo, I'm gonna show you what we've done is we simulated, adding smart capabilities to a camera in a manufacturing plant. Think, automated QA and QC. What we're looking at in Seth's screen is little 3D printed parts that we created. And what we've done, we then manually added some defects to them, things like broken teeth off of those little rings, dents, scratches, things like that. We then took that, we created a data set out of it, labeled some data, and trained a simple YOLO V5 model. And then through that open source project Seth mentioned, Chassis, we containerized that model, we deployed it to our Modzy instance, where we can then ship it out to different devices. So it's also worth noting that Modzy Enterprise, which I'm showing you right now, this is deployed in our cloud instance, and I believe in the AWS US West 1 region, so out in California somewhere. And in just a matter of minutes, what we can do is take these models from this hub and send it out to Northern Virginia at Seth's house. And so now what we've done is you see the plate is running right there. We've shipped this model. Modzy Core is running it on the Jetson Nano. So I'll just show you what this device group looks like. Seth walked you through this process. We've got a couple devices. We can see that this is healthy actually, because with 1.7 we've introduced this information sharing through that communication tunnel Seth mentioned. And with a couple lines of code, I'll choose Python in this case, I can essentially embed this into any application. So this code is running on the camera. The camera is taking an input stream, passing it through the model, and generating an output stream that I'll show you in a second. So the expectation is you'll see from the camera view what Seth's showing you with predictions rendered on top of it. So let me kick this off. And if I refresh this, what we see here are some live predictions being made on these little parts. Broken teeth, scratches, dents. And again, what we could do is kind of stream this information, hook it into, and you see Seth's finger right there, and we could hook this into some more comprehensive dashboard fairly easily. So very quick example of how you can take a model and deploy it directly to a camera to make it a smart camera in a matter of just minutes. So that's one example. Again, this falls under this design pattern or bucket of running machine learning models directly on traditional edge devices, something we call native edge. Well, another use case, let's take the factory floor as an example again. And instead of just having a single model that we're going to need to deploy to a camera, instead, you may have dozens of different sensors and dozens of different models that are required to kind of enhance the manufacturing flow, the worker flow, things like logistics tracking, QA, QC for computer vision, air quality index predictions, PPE detection for worker safety, and there's a whole collection of use cases you might run. Well, in that scenario, what you can actually do is deploy Modzy Core to an edge server, something like HP EL8000 as an example, where you could have dozens of models running, and it's a luxury that you don't necessarily have when you're working with very small form devices like this. This guy may be able to hold 1 or 2 models, total of 4 to 5, 6 gigs, right? But on an enterprise server, or edge server rather, you could have dozens of models that total 20, 30 gigabytes of disk storage. So what I'll do now is let's see, shift over to a bunch of terminals we have here. Actually, before I do that, let me show you a different device group. So in this next example, we'll kind of simulate that use case that I talked about. But in this case, we've created a performance testing device group that has 3 variants of the same image classification model. Now, you're also seeing some of our performance benchmark testing. In other words, how do we convert a PyTorch model into Onyx format and to OpenVINO format and get some significant performance acceleration. So what we've done is we've deployed all 3 of these models to an edge server. Let's see, that's this guy right here. And I know that there's a lot going on here, but so I'll direct your attention to the left terminal first. If I do Docker images right here, we see that this one image is 3 gigs, almost 4 gigs, right? There's a lot of disk storage being taken up here, 12 gigs or so. Again, because these are larger models, they're powerful, and they just require more space. So what I'll do is I'll run a similar command that of what Seth ran. And again, we see 3 model containers preparing and starting up, right? And so they're live and running. That's great. I can go back to my hub to make sure that say connection. This will come back in a second. I'll check it in a second. Sometimes it takes a little bit. And then what I'll do is run basically a couple lines of code that I could copy paste directly from my device group page to run inferences against each of these 3 models. And on the left, what you're going to see are a bunch of rapid logs as I kick these scripts off. So first is the PyTorch model, the next is an Onyx model, and the final one is an OpenVINO IR model running with the OpenVINO runtime. So I'll kick this guy off. We see immediately we've got tons of inferences happening. Similarly, the Onyx model is running as well, and now the IR model. We see that this ran 100 inputs very quickly in a total of 7,000 or so milliseconds for some throughput of about 13 to 15 images a second. And we can see some pretty significant performance improvements when we look at the Onyx and OpenVINO model results. Ultimately, about 17 to 25 images per second. So this is an example of how you can have 3 pretty large computer vision machine learning models running concurrently on a larger, what we'll call an edge server. It's just a different design pattern way you may take advantage of Modzy Core and the ability to ship models out connected to all different types of sensors and data sources.
Well, Brad, that was awesome. Cool to see so many inferences all running in bulk at the same time. Now, actually, I can jump back over to the demo we started just a second ago, because everything is now live and running and our models are up. So let me take you back here to our terminal. Again, this is live inside our Intel Upboard. We successfully pulled this container image with the BERT model I was showing you before. It's now live and running. So we should be able to talk to it, have some fun, play around with it. Well, let's do that. Let us show you how you can do that. Interacting with a Modzy Core model is really simple. We have an SDK in Python that you can use to interact directly with our gRPC interface, which is probably the fastest way you can probably work with it. So here we can see the model ID, the model version we're working with, and then the IP address of this particular edge device. This is right on my local network, so for me, I can just interact with this directly. If it's on a different network, you may have to create a tunnel or a pipeline, or you can run this code directly on that device. There's a lot of different ways to connect it. So once we do that and create our client, we can go ahead and start having some conversations. So, hello world. We'll go ahead and send that little message over to, our edge device. Oh, there we go. It looks like maybe some happiness, maybe with exclamation mark. We found a little bit of joy. I'm having a great day. And we'll go ahead and save that. Try this one, see if we get some different results. Try that again. And we can see here, oh, even more joy. Very, very joyful. What if we have a terrible day? Not that anyone would have a terrible day. Go ahead and save that. Again, send this over to our little single board computer, and all of a sudden we've got a lot of sadness. So this is working. The model's doing what it's supposed to do. It's doing what we expect, and it's happening really fast. So this is one of the cool parts of being able to orchestrate models on edge devices, is you can use them wherever you need to. And using the tools we built into Edge, you get really fast response times, low latency, which is one of the reasons why edge processing is getting so popular for scenarios where you're using computer vision for real-time, human safety type situations. It's really nice to be able to operate at this speed with this, minimum amount of latency, and to be able to process so many different types of data. This works for edge devices using computer vision. as we saw some text examples. This works with sensor data. This can work with audio data, signal data. It's agnostic with whatever type of data or models you want to use. It runs and works with all of them. And the SDK conforms to the exact same API standards that Modzy's existing API uses. So if you've written code to process data through Modzy in the cloud or Modzy in on-prem, you can use that same code with some minor tweaks to use the Python SDK that we've created to interact with all of those models right on your fleet of edge devices. So really flexible, really fast, really easy to use. We can't wait to see what kinds of contraptions you all are able to build with it, and look forward to adding some more features in the future. Long term, our roadmap includes adding in more collection from edge devices back to Modzy, being able to sample inference results right from a single hub across all of your devices, being able to access real-time drift information about those models out there in the world across that fabric of edge locations, and being able to more simply and easily build edge applications that use one or more models in more complex and sophisticated ways. So this is just the beginning of what we have planned, and I can't wait to bring you all along the journey. But no, this is great. Brad, thanks again for all the great demos. Anything else that you think our customers should keep an eye out for in 1.7?
No, I think you covered most of it. The only other thing I'll say is, we're really excited about this NATS transition. Opens up the door for lots of future features. And I don't know if you talked at all about security when I missed you when I was muted somehow. We're excited about 1.7. We're excited about NATS, and we're looking forward to seeing what you guys come up with. And stay tuned for more updates as we have them, in the next couple months.
Awesome. Brad, thanks so much. And talk to you all again soon.
Cool. Thanks, Seth.
Yeah, see ya.